Dynamics and control of bee flight. Bees are a vital part of our global ecosystem as they fly from flower to flower, pollinating nature. Their flight is an example of a controlled dynamic process which we will investigate within this video. Dynamics of bee flight. Bee flight is governed, as with all systems, by Newton's second law of motion, F equals ma. Based on the frequency at which they beat their wings and the amplitude of their wing stroke, they generate enough lift to counteract their weight to maintain steady flight. This dynamic process is continuous because the bee constantly takes in the sight of its surrounding in order to maintain the appropriate trajectory. Control of bee flight. In flight, the bee visually navigates its terrain based on optic flow. Optic flow is the apparent angular velocity of the surface with respect to the bee. When moving through passages, bees maintain equidistance between walls by trying to balance the apparent angular velocities of the surfaces. Bees take in the sight of its surroundings and uses it to determine the optic flow of the surfaces it's between. Error between these apparent angular velocities in conjunction with previous flight path is then used to determine the new flight trajectory. This is why it is a PI-controlled system. As seen in this video, as the bees move along the tunnel, they use this control process to continually improve their accuracy in maintaining equidistance between the walls. This is especially seen in the flight of the bee within the larger passage as it levels out its flight path to a steady state after being in a transient state at the beginning of the tunnel. In honeybee navigation en route to the goal, visual flight control, and odometry, researchers used a tunnel with two walls covered in black and white gratings to study this control process. When the gratings were stationary, the trajectory followed along the middle of the tunnel. If one of the gratings moved in the direction of the bee's flight, therefore decreasing the angular velocity of that wall seen by the bee's flight path was along the moving grating. When the grating was moved in the opposite direction of the bee's flight, therefore increasing the angular velocity of that wall seen by the bee's flight path was along the other wall.